Welcome back. Um, we now present a general version of the chain rule. Uh, let's let R be a function from the from U into the N space, where U is a subset of the M space. Um, so R, we can think of R as taking a point in the M space to a point in the N space, or we can think of the input of R as a vector in the M space, and the output of the function can be thought of as a vector in the N space. So let's denote the input of R by the point or the vector t1 comma t2 comma tm, and let's denote the output of the function R by the point or the vector x1 comma x2 comma xn. So notice, so then the components of the output, each of the components of the output here can be thought of a real valued function of these input variables t1 up to tm. So we can think of the first component of the value of R, x1, as a real valued function of the input variables t1 up to tm. And similarly, x2 can be thought of as a real valued function of the variables t1 to tm. Xn is a function of the variables t1 up to tm. Let's let z be a function f of the variables x1, x2, xn. And via composition of f and r, we can now think of z as a function of t1, t2 to tm. So z is a function of z is a multivariable function, real valued function of the variables x1 to xn. By composition of f and r, z can also be thought of as a real valued function of the variables t1 to tm. So now we want to know, then we can ask, what's the partial derivative of z with respect to t1, or what's the partial derivative of z with respect to t2, and so on. So let's say ti is let's pick ti where I is between 1 and m. So what's the partial derivative of z with respect to ti? With respect to ti, the partial derivative of z with respect to ti is equal to partial derivative of z with respect to x1 multiplied by the partial derivative of x1 with respect to ti plus partial derivative of z with respect to x2 multiplied by the partial derivative of x2 with respect to ti plus plus partial derivative of z with respect to xn multiplied by the partial derivative of xn with respect to ti. So notice that in the second factor of each summand here is a partial derivative with respect to the same ti. Okay, so let me explain this general chain rule in the next two examples. So let's say that I have a function z of two variables x and y, where each of the variables x and y are functions of s and t. So x is st squared and y is s squared t. So I made a tree here where, so we have that z is a function of x and y, x is a function of s and t, y is a function of s and t as well. And so we want to find the partial derivative of, so via composition, we can say z is a function of s, and then we can ask, what's the partial derivative of z with respect to x, with respect to s? Well, what we do is we say, okay, we take the partial derivative of z with respect to x multiplied by the partial derivative of x with respect to s, right here, plus partial derivative of z with respect to y multiplied by the partial derivative of y with respect to s. So now, what's the partial of z with respect to x? Well, with respect to x, we get e to the x sine y. Partial derivative of x with respect to s would be t squared. Partial of z with respect to y would be e to the x cosine y. Partial of y with respect to s would be 2st. And the partial derivative of z with respect to t, so in that case we go partial of z with respect to x, which would be e to the x sine y multiplied by partial of x with respect to t. Partial of x with respect to t would be 2st, and then partial of z with respect to y again is e to the x cosine y, and partial of y with respect to t would be s squared. So this will be the partial derivative of z with respect to t. Let's do another example. Let's say that now that we have w is a function of x, y, and z, and x is a function each of the variables x, y, and z is a function of r, s, and t. So x is rs e to the t, y is rs squared e to the negative t, z is r squared s sine t. Let's say we want to find the partial derivative of w with respect to s and evaluate that at r equal to 2, s equal to 1, and t equal to 0. So here w is a function of x, y, and z. X is a function of r s t, y is a function of r s t, z is a function of r s t. So by the chain rule, we know that the partial derivative of w with respect to s would be partial derivative of w with respect to x multiplied by partial derivative of x with respect to s plus partial of w with respect to y multiplied by the partial of y with respect to s, and plus partial of w with respect to z multiplied by partial of z with respect to s. So this w is a function of 3 variables, so we're going to get 3 summands in our partial derivative. In the previous example, z was a function of 2 variables and we have 2 summands in the expression for the chain rule. Okay, so now we have to calculate these partials. So the partial derivative of w with respect to x would be 4x cubed y, which is what I wrote here. Partial of x with respect to s would be r e to the t, which is what we got here. Partial of now w with respect to y. With respect to y, the partial derivative of w would be x to the 4 plus 2yz cubed, and partial of y with respect to s would be 2rs e to the negative t. Partial of w with respect to z would be 3y squared z squared, and partial of z with respect to s, so that's going to be r squared sine t, so r squared sine t. So once we plug those in, and now remember that I want to calculate that partial derivative we want to find partial derivative of w with respect to s when r is 2, s is 1, and t is 0. Well, when r is 2, s is 1, and t is 0, what are the values of x, y, and z? So when when R is 2, S is 1, and T is 0, what is X? So R is 2, S is 1, T is 0, e to the 0 is 1, S is 1, R is 2, so X would be 2. Okay, so X would be 2. So I got X is 2. And then Y, so R is 2, S is 1, e to the 0, so again Y is 2. Finally Z, sine of 0 would be, T is 0, so sine of 0 is 0, so the whole thing would be 0, so I don't have to look at anything else. Z would be 0. So 2, 2, 0. So here we're going to plug in 2 for X, 2 for Y, and 0 for Z. And then again, R would be 2, T would be 0, so here you get 2, e to the 0, X is 2, Y is 2, Z is 0 here, 2, R is 2, S is 1, e to the 0, and here sine of 0 would be 0, so this term would be 0 anyway, so I'm not going to bother writing it down. So from here we would be getting 128. From the second summand we are going to get 64, because this would be 2 to the 4 multiplied by 2 squared, so that's 2 to the 6, which would be 64, and if we add them we get 192. Okay, so I hope that explains the how to use the chain rule. In the next video we will be talking about implicit differentiation.